So in 9.6, we're going to look at something called the Pythagorean Theorem, and you're going to use this theorem a lot when you get into geometry. It's a very popular formula. Some of you may have already heard of it before. So this Pythagorean theorem is used to find the missing side of a right triangle. A right triangle. A right triangle is a triangle that contains a 90-degree angle. For those of you not familiar with a 90-degree angle is, imagine the floor and one of the walls in the room that you might currently be in. We're hoping that that floor and that wall are meeting at a 90-degree angle. Otherwise, it's leaning. And we want those walls to be straight up and down to the floor that you're walking on or that you're sitting on, okay? So a 90-degree angle is a perfect two sides that meet perfectly straight up and down and across. The Pythagorean theorem you can see is right here. It's a squared plus b squared equals c squared. So what the heck do those mean? Well, if I gave you this right triangle here, this tells you, this little box here tells you that that is a right angle, that's 90 degrees. If you do not see that little box in one of the angle corners, you cannot assume that it's a right triangle unless they tell you. So if you don't see this, it's not a right triangle and you can't use the Pythagorean theorem. So you've got side A, side B, and side C. A and B are your two shorter sides. They're the ones that kind of create the 90-degree angle. And they are called legs. C is the longest side. It's always directly across from that right angle. So when we're plugging things into the Pythagorean theorem, A and B you could mix up, but C always has to be the longest side. It has to be the side opposite of that right angle. So it is important that you're plugging the right number into the right variable of that Pythagorean theorem formula. Okay? So let's take a look at using this. Example 1 says, find the length of the hypotenuse of a right triangle whose legs are 6 inches and 8 inches. So that word legs right there is telling you that what they're giving you is sides A and B. So let's just call this A, 6 inches is A, and let's call 8 inches B. So we're trying to find the hypotenuse, which is always going to be your C. That's what we're looking for. That's our question mark. So using the Pythagorean theorem, we've got A squared, which is 6, so we have 6 squared, plus B squared, which is 8, so 8 squared, equals C squared, and that's what we're looking for, so we're going to leave it as C. Obviously, you can use a calculator anytime, so if you take 6 squared, that's 36, and 8 squared, which is 64, that gives us 100 when we add them together. And from that last lesson on solving, we learned that the opposite of a square is a square root. So I'm going to have to square root both sides in order to get that exponent of 2 to go away. Square root of 100 is 10. And the square root and the square cancel, so we're just left with C. We want to make sure to put the unit of measurement up here. We were told that the legs were measured in inches. So our hypotenuse is going to be measured in inches. So C is equal to 10 inches. We look at number 2. Find the length of the leg. So now we're trying to find either A or B of the right triangle shown. Give the exact length and a 2 decimal place approximation. An exact length is not a decimal. It's anything but a decimal. And then, of course, anytime you see approximation, that's when a decimal is coming into play. So we're going to have 2 answers here. So let's see the right triangle. So we can see there's our missing leg. So let's just call this leg up here A. So the one we're looking for is B. The longest side across from the right angle, that's our C. So we're looking for B using the Pythagorean theorem, A squared, which is 2, plus B squared, that's what we're trying to find, equals C squared, that was 5. So just plugging everything into that formula. 2 squared is 4. Leave the B squared. 5 squared is 25. Before we can square root, we need to get this 4 over to its like term, so we're going to subtract. So we have b squared equals 21. Now to get rid of this square, we're going to square root both sides. So the square root, the square cancel, so we're left with b equals square root of 21. From earlier, we looked at simplifying radicals. This one cannot be simplified because there are no factors of 21 that we know the square root of. So this right here is our exact answer. Notice though that in the triangle that the sides that were given to us were measured in meters. So the square root of 21 meters is our exact answer. To get the approximate, you simply plug it into a calculator. So you'll plug in the square root of 21. It says a 2 decimal place approximation. So we're looking at 2 numbers after the decimal. So in your calculator, you have 4.5 and then it says 8.2. The 2 is not going to do anything to the 8, so we'll leave it as an 8. Write the word meters next to it. So now we have our exact and our 2 decimal place approximation for the length of that missing side of this triangle. Let's look at one more. A surveyor must determine the distance across a lake at points P and Q as shown in the figure. So we're looking for this distance between P and Q. To do this, she finds a third point R perpendicular to the line PQ. Perpendicular is another vocab word that you're going to learn and hopefully really get to know when you're in geometry. But perpendicular means 90 degrees, basically. So if you remember, we're working with right triangles, that's 90 degrees. You're going to see that word perpendicular a lot. So this R is perpendicular, makes a right angle with that distance that we're trying to find. If the length of PR is 320 feet, so from P to R is 320 feet, and the length of QR is 240 feet, so between Q and R is 240 feet. What is the distance across the lake? So we're trying to find this side here. Approximate this distance to the nearest whole foot. So again, we know it's a right angle because of this word perpendicular up here. So we know we can use the Pythagorean Theorem. Let's see. Here's the right angle. Directly across from it is your C. So this 320, that's our C. Let's call this side here B. And let's say we want to find this side A. We haven't found A yet, so I might as well show you one where you're finding A and not B. So using the Pythagorean Theorem, we have A squared plus B squared, so 240, equals C squared, so 320. Definitely a calculator problem because we've got such big numbers here. So let's see, we've got A squared plus 240 squared is 57,600, and 320 squared is 102,400. Obviously, we need to move this 57,600 to the other side to get A squared by itself, so I'm going to subtract it. Those will cancel there, so we're just left with A squared on the left-hand side. And we'll subtract those two to get 44,800. And then finally, we can square root to get rid of that square. So we have A equals, we're going to square root that answer. It says to round it to the nearest foot, so no decimal places. In your calculator, you should have 211.660. That's 6. So let me write this down to show you really quick. So in your calculator, there's more digits than that, but I'm just going to show you this. So to the nearest foot means to this place here. So this 6 is going to bump that up to a 2. So my answer would be 212. In this case, it's feet. And that's going to be our final answer.